Okay, let us try to show that every positive, even integer, I forgot to write t out here, integer is actually of the form 2q, and that every positive odd integer, integer is of the form 2q plus 1. Now, where of course q is some integer. Okay, now how do we do that? Now just suppose a is any positive integer. Suppose a is any positive integer, and b equals to 2. Let's assume 2 to be our b. Now applying Euclids division lemma, applying Euclids algorithm, what do we get? A equals to bq plus r, so 2q plus r, where of course q is positive integer, so it's greater than or equal to 0, and r is 0 or r is equal to 1, because of the following reason. Because of course your r lies between 0 and should not be equal to 2. It should be less than 2, strictly less than 2. So 0 and 1, these are the two possibilities. So either 0 or 1. So applying that, now directly what do you get from here? From here we get that either a equals to 2q when r is 0, okay, and or a equals to 2q plus 1 when r is 1, right? So if a is of the form 2q, then a is even integer, of course, then a is even integer, and when it is of the form 2q plus 1, then that means it is odd integer. Now this is because any positive integer will either be even or odd, and of the form 2q will be even, and of the form 2q plus 1 will be odd.